What if I told you this is a square wave? It's got the same frequencies as a square wave, and it sounds identical to a square wave, but it looks completely different. If these two didn't sound identical, it's actually speaker distortion you're hearing. This waveform peaks higher and therefore distorts more. My built-in iMac speakers, for example, distort a lot, even at very low levels. To make this, I generated a pure 49 Hz square wave and phase rotated it 90 degrees using isotope RX. This rotates every frequency in the square wave by 90 degrees. Unhelpfully, we're now playing the same frequencies at the same loudness but using more headroom to do so. The square peaks at -14, but this phase rotated square peaks at -2. This is a problem because we've now capped loudness at a much lower level. If we use a limiter to maximize the square wave, just like we would in mastering, maximizing it in the audio file, and compare this to maximizing the phase rotated square, you can see the original square is significantly louder, 12-ish, using LUFS. In other words, it's the waveform that caps loudness, not just the frequencies involved. Usually we'd use this module to reduce how much headroom we're using it in adaptive mode to correct asymmetric vocal waveforms. Again, this doesn't have an audible effect on the audio, it just changes how much headroom the waveform uses. In this case, peak level is reduced, and so we can push our vocal louder before encountering limiting artifacts. Note, asymmetric waveforms is a problem for some microphones, like my Neumann TLM102, but not others, like my D80D3 Pro. Back to that phase rotated square. This is an extreme example, obviously, but it illustrates an important concept. That is, phase shift can change the height of a waveform in an unintuitive way. If you've ever done an EQ cutter or a notch and wondered why the level meter increased, why would peak level increase after removing frequencies? Phase rotation is why. You can see in Serum how phase is changed by typical filter shapes. Click the filter shape to see that filter's effect on phase for each part of the frequency spectrum. And to find out more about EQ and when you might need to consider phase, do see my course on groove3.com. I'm one of the course creators there, and they have courses on absolutely everything audio and music production related. Links in the description below. Naturally. Back to squares. Have you ever wondered why your square waves don't look like perfect squares? They look perfectly square in the synth, like here in Serum, but then the waveform has all these wibbles and wobbles. Wibbles and wobbles, wobbles and wibbles. There are two reasons: anti-aliasing and Gibbs phenomenon. If I generate a perfectly square wave using isotope RX, ignore the wibbly wobbly connection line, I'll come back to that. See how those square dots, the samples, create a perfect square shape? This perfect square seems like a good idea, but it results in what we call aliasing artifacts. These are unwanted sounds that result from the mathematics of sample rates and trying to draw a perfect square wave using a finite sampling frequency. At lower pitches, we see these aliasing artifacts as these frequencies here. And I'll let you decide if these artifacts are significant or maybe even pleasantly crunchy. At higher pitches, aliasing artifacts can significantly change the tone. Now, let's explain the wobbles. The wibbles and wobbles, the wobbles and wibbles. When the digital information, the squared dots, is converted to an analog signal or playback, the dots need to be connected with a curvy line. And when you try to connect the dots of a perfectly square square with curvy lines, you get these little overshoots. The mathematics is a bit more rigorous and nuanced. For example, the sample rate determines how curvy you could draw your curvy line. But this principle is called Gibbs phenomenon, and it's not a coincidence that an anti-aliased square looks very similar around the corners. If you see a square that doesn't overshoot in this wibble wobble style, zoom in enough and you see that the vertical bit isn't as vertical as it should be. Here there's more than one sample between peak and trough, and so it's not a true square wave. And consequently, compared to a true square, the high frequencies are rolled off. Fundamentally though, you don't need to understand any of this. I just thought you might find it interesting to know why your squares don't look like squares. My name's Multiplier. See you in the next one.